This section is called double angle, half angle, and product to sum formulas. In this video, though, we're just going to be talking about double angle formulas. The first one we'll talk about is the sine of 2x. Now, in this context, this 2x here is an angle. Let me highlight it. 2x is my angle. But another way to write the sine of 2x is as the sine of x plus x. And I have a formula, I know a formula for the sine of the sum of two angles. It's the sine of the first times the cosine of the second. It just happens that the first and second angles in this case are the same, plus the sine of the second times the cosine of the first. Simplifying this, I get 2 times the sine of x times the cosine of x. So the sine of 2x is equal to 2 times the sine of x times the cosine of x. I'm going to rewrite that over here. The sine of 2x is equal to 2 times the sine of x times the cosine of x. All right, let's take a look at the cosine formula. The cosine of 2x is equal to the cosine of x plus x. Well, the cosine of x plus x is the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. So I can write that as cosine squared minus sine squared. So I'll write that down over here as well. The cosine of 2x is equal to the cosine squared of x minus the sine squared of x. Now, another way to write cosine squared is as 1 minus sine squared. So let's do that. That lets me write this expression here. Let me highlight it. Cosine squared becomes 1 minus sine squared. And then the minus sine squared gets tacked on at the end. So I have 1 minus 2 copies of sine squared. So another way to write the cosine of 2x is as 1 minus 2 times the sine squared of x. If instead I write the cosine squared as cosine squared but change the sine squared to 1 minus cosine squared, then I get cosine squared minus 1 plus cosine squared, which is cosine 2 times the cosine squared of x minus 1. So there's a third way you can write the cosine of 2x. All right, let's take a look at tangent. The tangent of 2x is the tangent of x plus x, which is equal to the tangent of x plus the tangent of x over 1 minus the tangent of x times the tangent of x. And again, all I'm doing here is treating this like the formula for the tangent of the sum of two angles. It's just that in this case, those two angles happen to be the same angle. So if this had been a plus b, I'd have an a here and a b here, and an a here and a b here, but a and b are the same. I can rewrite this as well. It's 2 times the tangent of x over 1 minus the tangent squared. So tan of 2x equals 2 times the tangent of x over 1 minus the tangent squared of x. So now I have 3 new formulas. I can always derive these from the sum of angles formulas, but they're pretty common. They come up fairly frequently, so it's worth at least recognizing them, knowing them well enough to recognize them. All right, so I'll leave those there for now, and I'll erase the rest of the screen, and then we'll do some examples. Here's our first one. If the cosine of x is 3 over 8, that's adjacent over hypotenuse, and x, the angle, is in quadrant 1, find the sine of 2x. Well, we know that the sine of 2x is equal to 2 times the sine of x times the cosine of x. We know the cosine of x. It's given to us. It's 3 over 8. So all we need to do is figure out what the sine of x is. if I draw an angle in quadrant 1 that has a cosine of 3 over 8, then I can find the length of the third side. This is my angle x, because I made this the adjacent. That'll give me the third side, using Pythagoras will give me the third side, and then I'll be able to figure out what the sine of that angle is. So let's see if we can figure out what this is. It's going to be the square root of 8 squared minus 3 squared. That's the square root of 64 minus 9. And that's the square root of 55. So the third side here is the square root of 55. So now I can figure out what the sine is. It's the square root of 55 over 8. I can reduce this, and I have 1 times 3 times the square root of 55 over 4 times 8, which is 32. Let's take a look at another one. In this case, we have a problem that looks like the right-hand side of one of my identities here. I have the cosine of 2x on this side and cosine squared minus sine squared on the right-hand side. Well, this is the cosine squared minus the sine squared. So what I'm looking for is, what is a? Well, notice that the right-hand side gives me that x equals 30 degrees. But the right-hand side is equal to the cosine of 2 times whatever the angle is. And the angle is 30 degrees. So this whole thing, 2 times 30 degrees, well, that's 60. So a is 60 degrees. What if instead of an actual degree measure here, though, I gave you something like the cosine of 7x squared, the cosine squared of 7x minus the sine squared of 7x. And I said, well, now what is a? Well, again, the fact that that's in the form of the right-hand side of this formula tells me that x must be 7x. That's a little misleading. If I rewrote this as the cosine squared of t minus the sine squared of t, or theta or something, that might be a little bit less confusing. So in this form, I would say that t is 7x. So since t, change that here, t is 7x, the left-hand side must be 2 times 7x, and I get the cosine of 14x. Therefore, a is 14x. Okay, this time I'm going to do another one like I did up here, but I've changed a few things. First of all, I'm going to use the cotangent of x. I'm going to be given the cotangent of x is 3 over 4. I'm still in quadrant 1. Another way to write quadrant 1 is to recognize that x is the angle, and if I say that x is between 0 and pi over 2, well, that means I'm in quadrant 1. Remember, this is 0, this is pi over 2. So saying that your angle is between 0 and pi over 2 is equivalent to saying that you're in quadrant 1. All right, let's take a look at what we've been asked for. We've been asked to find the tangent of 2x. Well, we have a formula for the tangent of 2x. It's 2 times the tangent of x over 1 minus tangent squared of x. Well, I don't know the tangent of x, but I do know the cotangent of x. It's 4 over 3. Now, tangent is opposite over adjacent, so cotangent is adjacent over opposite. I could do this with a triangle and then say tangent is adjacent, opposite over adjacent, and take that to be 3 over 4. Or in this case, I could just recognize that cotangent and tangent are reciprocals of each other. That means that the tangent of 2x is equal to 2 times the tangent of x, which is 4/3, over 1 minus the tangent of x squared. That's going to give me 4 times 2 times 4, which is 8 over 3, over 1 minus 16 ninths. Well, 9 ninths minus 16 ninths is negative 7 ninths. And then if I invert and multiply, this gives me 8/3 times negative 9/7, which reduces. And ultimately I get negative 24 over 7. And that's my answer. It's 24 over 7. What if I gave you a problem like this, but I asked you to find, for example, the tangent of 3x? Let's take a look at that kind of example on the next screen. Here, we're asked to find the sine of 3x. I'm given that cosine of x is 3 over 7. I'm given that the angle x is in quadrant 1. Let's figure out what the three sides of that triangle are. I'm in quadrant 1, and the cosine of my angle x is 3 over 7. That means adjacent over hypotenuse is given by those two values. The third side is the square root of 49 minus 9. Well, that's easy. Square root of 40. I could write that as 2 root 10. That might be a little nicer to work with. Now, sine of 3x, I don't have a formula for that, but I do know the sine of the sum of two angles. So this could be 2x plus x. If I treat x like one angle, 2x like one angle, and x as a different angle, which they are, they're different sizes, then I can use the sine of sums formula to write this as the sine of 2x times the cosine of x plus the sine of x times the cosine of 2x. And I know a formula for the sine of 2x, and I know formulas for the cosine of 2x. So let's rewrite this one more time. The sine of 2x can be written as 2 times the sine of x times the cosine of x. Then I have a times, and then I have another cosine of x. Plus the sine of x times, now I have three different formulas for the cosine of 2x. I can use whichever one I want, but sometimes it's more appropriate to use one than another. In this case, it doesn't really matter because all three of my formulas end up with sines of x and cosines of x in them. Some of those are squared, but I don't have the sine of 2x or the cosine of 2x in any of those formulas. Once I've changed it from the cosine of 2x, the 2x is gone, and that's really all that matters in this case. Keep in mind, though, that sometimes when you want to use one of these formulas, it does actually make a difference which of the three cosine of 2x formulas you use. Sometimes it'll be easier to use one, and sometimes it'll make more sense to use a different one. So let's for now just pick the cosine squared of x minus the sine squared of x is the formula that we'll use here. That gives me 2 times the sine of x times the cosine squared of x plus the sine of x times the cosine squared of x minus the sine of x cubed, the sine cubed of x. So I have 2 times whatever the sine of x is times whatever the cosine of x is squared plus the sine times cosine squared minus sine cubed. So now all I have to do is figure out what sine and cosine are. Here's my angle x. The sine of this angle is root 40 over 7, or 2 root 10 over 7. So everywhere I saw a sine, I'm going to write 2 root 10 over 7. 2 root 10 over 7. The cosine of that angle is 3 over 7. In fact, I was given that. So I can just write 3 over 7 wherever I see a cosine. And now I can simplify. This is going to be 9 over 49, but it's multiplied by 2. So that's going to be 18 over 49, and then I'm going to have times 7 again. I think I'll just do this off screen. I have 2 times 9 in the top. That's 36 times root 10 over, and then I have 7 times 7 squared, which is 7 cubed in the denominator. That works out to be 343. And 36 over 343 doesn't reduce, so I'm going to leave that just like that. 2 times 3 squared is 2 times 9, which is 18 times root 10 over 7 cubed, 343. And conveniently, I have 2 cubed times root 10 cubed over 7 cubed. The 7 cubed is going to be 343 again. 2 cubed is 8. Now the square root cubed, root 10 times root 10 times root 10, gives me a root 10 times root 10, which is just 10 times root 10. So altogether, I have 36 plus 18 minus 80 root 10s. That's negative 26 root 10s. And that's all over the common denominator of 343. Now, 26 over 343 does not reduce, so this is the answer in its simplest exact form. There you go. The other thing we can use these for now, of course, is to prove identities. Let's take a look at one of those examples on the next screen. Here, we've been asked to prove the identity that sine plus cosine quantity squared is equal to 1 plus the sine of 2x. Let's take the left-hand side and copy it down over here. I'll start by writing left-hand side equals, I'll copy out my left-hand side, put it there, and then I'll start playing around with the left-hand side, initially by expanding it. This is going to give me sine squared of x plus 2 times sine of x times cosine of x plus the cosine of x squared. If you don't believe that, try rewriting this as sine of x plus cosine of x times itself. And then use distribution to rewrite this expression. You end up with this. Now notice that I have a sine squared plus a cosine squared in my expression. So let's reorder that. Sine squared of x plus cosine squared of x plus 2 times the sine of x times the cosine of x. Well, sine plus cosine, wrong pen, sine plus cosine, sine squared plus cosine squared rather, is equal to 1. So I can replace that with 1, and then I have plus 2 sine x cosine x. And that's 1 plus. Now I need to use the knowledge that the identity sine of 2x is equal to 2 times the sine times the cosine of x, that those two things are equal. So I can rewrite this as the sine of 2x. And that is my right-hand side. So my proof is complete. Now, naturally, there are a lot more things we can do with this formula, but we still have a lot of ground to cover in this section. In the next topic, in the next video, we're going to be talking about half-angle formulas.